Hello and welcome back to another video. In this problem, we're asked to find the functions f of g of f, g of g, and their domains. For f of x is equal to x over 1 plus x, and g of x is equal to the sine of 2x. So first we have f of g. So this is f of g of x, which is the sine of 2x. Therefore, we have plugging in the sine of 2x for x. We have the sine of 2x over 1 plus the sine of 2x. B, we have g of f. This is g of f of x, which is x plus 1 over x. Therefore, this is equal to sine of 2 times x over 1 plus x. This is equal to the sine of 2x over 1 plus x. F of f equals f of itself, x over 1 plus x. So we plug in this fraction wherever we see x. So this is x over 1 plus x over 1 plus x over 1 plus x. This is equal to, I'm going to do a little bit of simplification because it'll make finding the domain easier. X over 1 plus x over, this is 1 plus x over 1 plus x over 1 plus x. Therefore, this is x over 1 plus x over 1 plus x is 2x plus 1 over 1 plus x. Dividing by a fraction means we can multiply by its reciprocal, x over 1 plus x, times 1 plus x over 2x plus 1. Therefore, this is equal to x over 2x plus 1, because these cancel. And we will get to the domain restrictions in a second. They are a little bit more complicated for that one. And then g of g equals g of itself, sine of 2x. Therefore, this is the sine of 2x. Therefore, we have a, b, c, and d. So the only restrictions on these functions are denominators being equal to 0, because the sine function can take any value. So here, the sine of 2x plus 1, I'll write that down here, right? It's for the domains. 1 plus the sine of 2x cannot be equal to 0. Therefore, the sine of 2x cannot be equal to -1. And we have to think about for what value does the sine of x equal -1. Therefore, this 2x cannot be equal to 3 pi over 2. And this is, here, x is not equal to, dividing by 2 on both sides, 3 pi over 4. There's the caveat that the sine function is cyclical. So not only is this value going to output a sine value of -1, but if we add any multiple of 2 pi, it's also going to do that. So we multiply by 2 divided by 2, because when we're dividing 2x to x, this 2 disappears. So the answer is 3 pi over 4 plus any multiple of pi, positive or negative, right? That's for A. For B, the only restriction is that this denominator, 1 plus x, cannot equal 0. Therefore, x cannot equal -1. For C, this denominator can also not equal 0. Therefore, x cannot equal -1/2. However, we lost a little bit of information here. When we cancel out 1 plus x, that also cannot be equal to 0, because it's in the denominator of the function. We canceled it out, but that doesn't mean that the original restriction for the original function wasn't there. Therefore, x cannot be equal to -1/2 or -1. And then for D, the sine function can take on any value. Therefore, the sine function is taking on any value. It can take on any value, all real numbers. So we have function a, f of g, with its respective domain. We have function for b, its domain, c, and its domain, and d with its domain. For these compositions, for f of x is equal to x over 1 plus x, and g of x is equal to the sine of 2x.